Hi everyone, just wanted to take a little bit of time to talk about how to find the distance between two parallel lines. Obviously, parallel lines go on forever and never intersect, so therefore they have an equidistant, or they are equidistant from each other at all points. The only thing we need to define and be careful about is what exactly that distance is, right? Because if I go from here to here, that's a different measurement than if I went like that, right? So, what we use to define the distance between two parallel lines is we talk about the perpendicular between the two of them. So, we find the line that would be perpendicular to both lines, because remember, if something's perpendicular to one line and that line's parallel to something else, it's perpendicular to both parallel lines. Um, so, we find the perpendicular, and then we find the 2 points of intersection, and we find the distance between them. And that's what we call the distance between the two parallel lines. So we do a method called essentially finding the perpendicular to get that information. So this is not a necessarily hard topic. It's just kind of long. The math itself isn't anything you can't do. You've done all this math before. It's really just a matter of doing it all. Right. So essentially, our first step every single time is going to be write the equations of our two parallel lines. Well, we have them in this case. So step one, check, right? We already have them. Down here, as you can tell, we're not going to have them, so we are going to need them. So here's what we're going to do now. We need to find the perpendicular line, so we need to find the perpendicular slope. So step two, find the slope. Well, the slope here is -2. The perpendicular slope is 1/2. Okay, so now what do we need to do? Well, let's move on to step three. We need to find a point on one of these two lines. Doesn't matter which point, I just need a point on one of them. So let's just take this line for instance. I'm going to pick a really easy point. The easiest point that I automatically know is already on our line is 0, 5. Oops, 0, 5. That had a lag there. Sorry, 0, 5. All right, so 0, 5 is on this line. That is actually our y-intercept. And the reason we're picking the y-intercept is because, well, that just makes life easier, right? I mean, I could pick any point, but this one just makes things nice. So why not? All right, now, step four. We now need to find the equation of our perpendicular line. And we have a slope and we have a point. So really now all we need to do is just put it all together. So we have y equals 1/2 x plus b. Well, what's going to happen? If I already picked the y-intercept and it's perpendicular through that point, that also means that 0, 5 is going to be on this line, right? So if you plug it in, it would just be 5 equals 1/2 times 0. Well, what does that make b? Well, that just is going to make b 5. So when you pick an intercept, not only does it make it an easy point to work with, but that means that your perpendicular line will have the same intercept. So my equation is just 1/2 x plus 5. See, it's not hard. It's just you have to remember all the different steps. So now, step 5, well, we need to find the point of intersection between these two lines and my newfound perpendicular line. Well, I already have one of them, right? This handy dandy point right there. That's fine. So we've already checked off this line, right? So now we need to find the point of intersection between this line and my second line. So this is probably the hardest part. I'm just going to set them equal to each other. So I get -2x minus 5 has to be equal to 1/2 x plus 5. So 5, add 5 to both sides, add 5 to both sides. Subtract 1/2 from both sides. The 1/2 x, subtract 1/2 x. So this is the same as -5 halves x plus, is equal to 10. Multiply everything by 2, I get -5x will equal 20. So x is equal to 4. All right. So now I have my x coordinate. I'm going to plug that in. It does not matter which one I plug it into because they have the point of intersection, right? So I'm just going to plug it into that one as a fraction. Why not? So y will then equal 1/2 times 4 plus 5, which is 2 times 2 plus 5, which is just 7. Okay, so now I have 2 points. I have 0, 5, and I have 4, 7. Okay, so now I have 2 points. You can find the distance between those 2 points now. You have the technology to do this. The distance formula, your change in x's minus squared plus your change in y squared. So 4 minus 0 squared plus 7 minus 5 squared, minus the square root of 16, right? That's 4 squared, plus, what's this, 2? 2 squared is 4, so the square root of 20. Now, the most annoying component of this sometimes can be the simplification. So the square root of 20, that's the same thing as the square root of 4 times the square root of 5, which is just 2 square roots of 5. So my distance between my two parallel lines is 2 square roots of 5. And it does not matter, again, which point you pick, but as you can tell here, picking a really nice point makes things easier. Additionally, it does not matter where you drew the perpendicular line. Again, you can go through any point. The distance will always be 2 square roots of 5. That being said, if you make this harder for yourself, it's going to take longer. So please, please, please be smart about which points you pick. Okay, so let me scroll down to this next one, and this one is going to be a little bit longer because I actually have to find the equations of my lines. Okay, so find the distance between the line formed by 1, -5, and -2, 10, and then by 4, 6, and 6, -4. Okay, so first of all, we do have to just confirm that these are actually parallel. And if they are not, that means I made a mistake when I wrote these points down. But also, it would mean that this would not apply, right? So 10 minus, which is a plus of 5. So the slope of my first one, called slope 1. So 10 minus, which is plus 5, and then -2 minus 1 is -3. That gives me 15 over -3, which should be -5. All right, again, let's just verify this. So I would have -4 minus 6 over 6 minus 4, which is -10 over 2, which is -5. Okay, so we're good. These are parallel lines, and they both have a slope of -5. All right. So I'm just going to find the equations of them. So y is equal to -5x plus b. And I'm going to do this for the first one. So I'm just going to plug in -5 is equal to -5 times 1 plus b, which makes this -5 equals -5 plus b. So b will equal 0, which is a very nice line. So that means my first line over here, I'm just going to write it, y equals -5x, and I have no b. All right. So let's do the second one. I'll use the other method. Y minus 6 is equal to -5 times x minus 4. Y minus 6 equals -5x plus 20. So y equals -5x plus 26. Okay, so we have y equals -5x plus 26. Okay, so I'm just going to go and clear that. So that's our step 1. I got my lines. And now we need to move on to step 2, which is ultimately going to be finding the perpendicular slope. Ah, okay, so now we need to find, so that's our step one. We found the equations of our lines. So step two, I'm going to find my slope. Well, I just flip it and change the sign, so it is 1/5. Now step three, I need to find a point. All right, so I need a point. I'm going to pick a y-intercept. I'm going to pick the nicest y-intercept I can possibly pick. So I could put 0, 26, or I could pick 0, 0. Now, you can pick 0, 26 and make it slightly harder for yourself, or you can just pick 0, 0. Remember, this comes up a lot, okay? So it's most important to just pick the easiest one. Now, I need the equation of my perpendicular line. Step 4. And remember, we've already used this line, so remember that. We've already used that. So if this one has a y-intercept of 0, so won't this line, because it's going through that point. So I have y equals, apparently I was holding the thing, sorry. So I have y equals 1/5 x. Okay, so I have y equals 1/5 x. Now, I need to find a point of intersection between this line and the other line. Again, I can't use this line. I've already done it. So I'm going to just set them equal to each other and say that 1/5 x is equal to negative 5x plus 26. So that would make this 26 fifths is equal to 26. So ultimately, what's that going to make x? X is going to be equal to 5. All right, and I got the 26 fifths because this is the same as negative 25 over 5. I add it to the other side, I get 25 over 5 plus 1/5. So I get x is equal to 5. All right, so I'm going to plug that in. I get y equals negative 5 times 5 plus 26. So y will equal negative 25 plus 1. I'm sorry, plus 26. I was getting a little ahead of myself, which makes it equal to 1. All right, so now I have my point. So that was my fifth step. So I got my new point, which was 5 and 1. Okay, so now I just need to find the distance between them. Again, pick the easiest point. That made things much easier for me. The other thing to consider is make sure when you're plugging in and figuring out the point of intersection that you're using this line, because otherwise you're just going to solve for the point of intersection you already have, and it's not going to work. So you need to make sure if you use this one's y-intercept, you then use this one to find the other point, okay? So just be careful. If you do that all out and you do it the other way, you're going to get a distance of 0 because you've used the same point. So let's actually find the distance now. So my change in x, well, luckily we're doing this with 0, 0, so this should end up being 1. 1 squared is 1. And this is 5 minus 0, which is just 5, and 5 squared is 25. Okay, so easy enough. We have the square root of 26. Sadly, I can't simplify that at all, so I'm going to leave it alone. And that's all my answers. The square root of 26. So as you can tell, it's not terribly difficult. It's just if you don't pick the nicest points, it's going to make things way harder for yourself. Okay, and they do take a little bit of time, so take your time and be careful. You don't want to do this multiple times. Have a good night.